Good morning, everybody. Morning, Ian. Welcome. Have a seat. I didn't get a chance to introduce myself, so I guess I should do a very short introduction at the moment. I'm William Wong. I have a background, a very varied background. I'm ex-military, ex-Singapore Air Force, gone into academia, and I have a strong interest in the area of human-computer interaction, particularly from a human factors perspective. I'm interested in how people make decisions. Naturalistic decision making is an area which I'm quite concerned with, and how those observations about how people make decisions in the real world can lead us into insights about how we design interfaces and systems. And at the moment, I lead a number of visual analytics projects, as well as the UK back and some of the projects that we are involved with there. And also at the moment getting another project off the ground that will bring together very many different layers of technologies and user knowledge as well, ranging from the engineering right through to the data manipulation, semantic extraction, visualizations, assembly of evidence in order to support human sense-making, insight generation aspects of visual analytics. So that's something that we will be doing, and I hope that you will find at the end of the week that it is not a narrow sliver of work, but it is visual analytics is an area that allows you to bring things, many different disciplines together, and that if they can be wielded very synergistically, you find that the real power comes in its combination, not in the isolation. Right. I'm going to give you a very brief introduction. I hope it's very brief. I think it was about 60 slides the last time I counted. Yeah, so hopefully we should be able to shoot through it reasonably quickly. I'm going to go through a number of different areas, okay, and I'll try to give you my sense of how visual analytics has come to where it is and what it is about. So to start off, I thought visualization is a good place to start, but very briefly, Ross will give you a lot more details about those, and then he'll also cover a lot more about the technical side of the visual analytics. I'm going to give you, hopefully work on the frameworks and the concepts that help you piece together where things fit together. Visualizations are visual forms that bring together concepts to help us to interpret, tell a story, okay, explain or make sense of data. Now that, for me, is a very important aspect or element of what we're trying to do with visualizations. Okay, visualizations have been around with us for forever. I mean, these are some of the caveman drawings found in France, in caves, yeah, centuries, hundreds of years ago. It's not new, but they tell a story. Same human function. They talk about the animals, the hunts, and how they've gone about trying to capture these animals on a particular hunt. Since then, they have improved, and since then they have matured quite a fair bit. And I believe most of you are familiar with this William Playfair's graph on the balance of payments, England and other countries, Denmark and Norway, exports, imports. And it starts to show, I mean, this is before people started putting numbers into visual forms. And this is quite historic in the sense that this is one of the very first attempts at being able to communicate how numbers move around. Okay? And you can see different lines, and you can see how the balance of payments changes quite easily without having to study those numbers. So you're familiar with these kinds of concepts. Another form of representation of visual forms is this. For most of us, you can't read Japanese, I presume. Yeah? But from the pictures, from this visual form, you can tell, assuming that this is time of day, when the greatest numbers of trains are going to be arriving at this particular station. You don't have to read it. You can tell it by simply looking at it, right? And you can see which time of the days. There are very few trains arriving at a particular station as well. It's straightforward, and it is this visual affordances that helps you interpret a lot of the data in ways that helps us make sense of it. And it's easy, it's structured. It gives you a certain amount of understandability. The next slide. I like the first person to just tell me, what is it that you see, okay? What is it that catches your attention, and what is it that is important to you? Let me see if I can get out of the way so that people here can see it as well. Am I in the way? Yeah. Okay. Very quickly. What do you see?
Chart junk.
Sorry?
Chart junk.
Okay, chart junk. What else do you see? What's the message?
Some few numbers.
Okay, what else do you see? Some numbers, some percentage. Okay, what else do you see?
It's a lady.
A lady. Ooh, yeah. That's it. Yeah, we saw the lady.
Oh, I see.
Somebody's honest at least. We saw a lady, yes. But here is, some of you are probably familiar with this particular piece of graphic found in the Tufte's book. Now, but the message is trying to communicate this line, not the legs, okay? It's the pink line. It's the price of diamonds over a period of time. Now, we can embellish our data so much that we forget what the message is about. And the rest of the embellishment become distractions. And it's very easy to do that with any kinds of data. Sorry?
How do diamonds know the shape of a woman?
Yep, very difficult. This is the price of diamonds has increased. So unless somebody told you about it, it's sometimes quite difficult to plow through what the distractions are about. A lot of work passed back in the late 80s and early 90s. For example, C. Melody Carswell looked at 3D graphics versus 2D graphics in trying to tell statistics data. And he found that 3D graphics were impressive because at that point in time it was nice and it was novel on computers, were less accurate in terms of performance than 2D graphics. It's harder for people to tell what the information is and where they lie in that 3D space for a variety of reasons. But embellishment doesn't necessarily lead to performance. And I think that's one of the things that we, in the area of visual analytics, got to try to remember. What we're trying to do is to accurately represent and to be able to communicate what is it that we're trying to represent correctly to another group of people. Here is another interesting graphic. It won the graphics award for a particular week, whenever it was for the O'Reilly. Again, there's a lot of data in here, and trying to understand what it is has another page that explains what it is. Very difficult to follow. Now, it may be the most efficient form in which the person has represented it, but what it shows is that little blobs over here are topics, and the colors of the topics are color-coded over the last 100 years in which the popular science magazine has been in place. And it shows across here different themes that have been present in the area over the last 100 years of the magazine. Again, it's difficult, it's hard to see any meaning in it because you have summarized so much of it into little blobs and circles. Useful? Interesting? I don't know. I find it very hard to find the information I need in them. Maybe you require some other thing, but these are visualizations. Okay? They are destination points. Somebody has done a lot of work to get to these kinds of historical trends, and then he has to then present the stuff. It's the data end, right? If you wanted to make changes to it or find out more, you've got to go into something else and find out more about it. So this is where we talk about this visualization pipeline. Okay, raw data somehow or other converted, maybe some have tables, analysis, or whatever, so that you find some kind of visual mapping in terms of visual structures, as we have seen in this one over here, and then generated into some kind of view. It's a one-way pipeline. Okay, a lot of data analysis, chunk it up, crunch it, and then finally show what you've done with the data states. Okay. There may be a certain amount of human interaction that goes back, but after you've done it, right? Sometimes we try to speed this up with better machines, faster software, better processes, but it's still one way. Okay. Here's another model that people talk about as well in terms of the visualization pipeline, but essentially it is still a one-way process. There may be a certain amount of interactions at each of the stages, but it is the same thing. It is a one-way process. Visualizations do that. Okay, and that's where we've been used to. Those of you who've done statistics and all that in the past, you do the number crunching, you do the analysis of the data, and then you find some way of showing what the data means in some kind of graph. Right? That's visualization. Okay, so we talk about unidirectional flow and how you repeat that. And then, over time, we started to see that people recognize that this is a limitation. Okay? It is not a fault in the way things are being done, but it limits what you can do. So people started to look at how can you create visualizations that are a bit more dynamic in its flow and its representation. And some of the work here goes back very, very several decades, right? But the purpose here, again, in terms of dynamic visualizations, is varying the search and retrieval gates to filter the data. So when you filter the data, you still hold the same visual form, but you're filtering the data so that you show different types of data in the visual form. What do I mean? Some of you may have seen this, but it's one of the earliest, if not the earliest, attempt at dynamic visualizations. Ben Schneiderman in the Human-Computer Interaction Lab at the University of Maryland, way back, although it's published in 1994, I believe he did this work back in 1992, which was then shown there, right? So, what were you guys doing in 1992? Anybody?
I was in primary school.
Oh, okay, right, 1992.
I just started a new research area.
Yeah, 1992. Well, I just left the armed forces.
I was waiting for Ben Schneiderman's next paper.
Yeah. Whoa. I'm just going to run this. I'm going to run this video. This is what they call the home finder. All right. What it was titled as a dynamic queries for visual information seeking. Over here is the screen that describes all the homes for sale within the Washington D.C. area, and I believe that is the Potomac River. Yeah. So that's the geography around the area. Let me see if I can start this thing up. Wish me luck. Did it run? No. Okay. Sometimes you need to do it differently.
Looks like it's just a picture.
No, it's not. It shouldn't be.
PowerPoint and visual analytics.
They don't go together. Yeah. Just give me a moment. I'm just trying to find the. Okay.
I think it's just a screenshot. I think.
No. Oh. It was working. Yeah. This. All right. Excuse me for a moment.
demonstrate the query components and the results and provide rapid and immediate feedback. For that, I'll take a look at the demo here on this display. Just move over to the side here, and we see on it a map of the Washington, D.C. area with the Potomac here. And this is an improved version of where we were a year ago in terms of dynamic home finder. Here's the mark where you want to work here at the University of Maryland, right about there, the A marker. And then your spouse is going to work downtown in the executive office building, right about over there. There's the B marker. Okay. And now each of these points of light on the display represent a home for sale. And if I move to the right, I can control this display by choosing the distance that I want to be from point A. And now it's set at 30 miles, and I'm going to bring it down. And you can control rapidly, incrementally, and reversibly the distance that you wish to be from point A. So let's say you decide, you see there's plenty of them, so you say you want to be, let's say, 5 miles from work, so that you could, let's say, bike to work. And now you want to be somewhere inside that range from B, so you slide down, and we now can see the set. And this is, looks like we've got about 40 or 50 homes over there. If I now choose about the number of bedrooms, I really want 3 or 4 bedrooms, so I move this double box slider to be 3 or 4. I've still got about 30 houses on the display, so why don't we look at the price now, and we want to keep the price down, let's say about 170,000, between 140 and 170,000. And that's given us a set of about a dozen here. We could trim a little further by choosing, we can choose from houses, townhouses, or condominiums. Let's eliminate the townhouses and condominiums, so we're selecting only houses. Yellow indicates selected field, and I can see now I've got about 10 of them. If I click on any one of those points, if I just click here, then the bottom of the display gives me a description of that house. Tacoma Park, a newer middle-class neighborhood, colonial brick, and fireplace, garage. And
okay, I thought that would be a very quick way just to show you what some of these systems are doing. They have done that. That's what they've been doing for quite some time now. Nothing new, but what they have been doing here is filtering information dynamically. They're changing the values, the parameters, but same parameters, same visual form. You can't interact with that display itself. Okay? Systems does a lot of wonderful things automatically. Okay. All right. And then a very short, quick history. Now, back in 2002, 10 years later, the visualization side of things have moved very rapidly. Okay. Now they're starting to say, look, how do I control the interaction? How do I visually control the interaction rather than just using sliders and click buttons or whatever in order to control the manipulation? So we're talking about visual exploration and the concept of visual data mining. This was put up, one of the earlier papers selected by Daniel Kime. A very interesting paper about the use of manipulating the graphics, the graphic elements in order to give you a chance to control the kinds of dimensions you want to see and how those dimensions pan out in terms of its representation. This was work done by Daniel and his group, I think when he was still in AT&T Labs. Parallel coordinates is one of the examples that he was doing. But what's more interesting was that he started to classify how these things work together. Okay, he talks about a classification system that looks at the different types of data, from multi-dimensional data to the different types of information that is available in those kinds of areas. And then the kinds of displays in terms of the visualization techniques, you could put just about any other thing along these scales. They're nominal scales rather than anything else. And then you talk about different ways in which you distort and interact with the data. And I think by this time, some of the linking and brushing techniques were starting to come into play, where you're now starting to work with the interface, where the data no longer is sort of a process and a final destination, but the data now starts to represent the interacting mechanism. So like, for example, by linking and brushing, the brushing mechanism, if you swipe a bunch of data, it shows you where they are in the data set or in another visual representation. And if you can manipulate those, you start changing some of the computations behind those data that it represents, the weights or the values, for example. Right. So he started to give you another view into these things about interactive visualizations. And then about the same time, the group in the Pacific Northwest National Laboratory, Jim Thomas and his team started talking about this concept of visual analytics. Not just data mining, not just a way of visually controlling information, but a way of supporting human reasoning. Okay? How visualizations, if they're created in an interactive manner, would allow you to then support the way we reason about information. Particularly this time coincided with the 9/11 problem. You heard about the famous problem about connecting the dots and why the different intelligence services in the US were not able to bring the information together. So one of the challenges that was set up for the Department of Homeland Security after 9/11 was to bring the intelligence services together so that they could share the information and information in a way that allowed people to rapidly find what was partial information in one organization and partial information in another, and how they could be connected together in order to help you make sense out of this very large set of information. So that's where this term started to come around. It is from that work that the PNNL was funded under the program called NVAC, the National Visualization and Analytical Center, to carry out this task of creating a technology. And as a result of that, you find that Jim saw a greater vision beyond the intelligence domain. So he started going around the world, Germany, where we now have a huge group of people involved in that, from Constance to the Fraunhofer group as well, and so on, to Australia, to South America, to talk about other applications to visual analytics. They're familiar with this picture from Inspire about an example of how you can create a data space, a data terrain representation of what the data sets represent. From the earlier examples we've seen previously, this one, it is very hard for you to tell what's in it. What is the data within it? What does it represent? So as a result, some of these kinds of shortcomings, they started to look at how do we semantically tell what's in there? What are the themes, what are the common threads in the data set? So these are semantic hills, so to speak. The peaks tell you what are the most common stories that are available in that data, making use of different types of technologies. It is not just simply getting quantitative data together and then summing them up, right? So we have a definition where a number of people have written about it. Park Chung talks about this. An outgrowth of the fields of scientific visualization that focus on, here, the science of analytic reasoning supported by interactive visual interfaces. Welcome, come on in. Yes, it's all right. Yeah, and in this particular set of view, we start to see the beginnings where we don't just show a graph, but this graph is tightly embedded, coupled together with a particular tool. In this particular case, in Inspire was a tool called Rate and Task. Rate stands for Rapid Attribute Knowledge Extraction.
That sounds about right.
Yeah, and CAST.
Pretty sure the K stands for keyword.
Keyword extraction, I thought so. Okay, keyword extraction. And then CAST stands for clustering something. Okay, But one basically does semantic extraction. What are the interesting themes? And the second part of the software called CAST does clustering of those themes into areas, keywords, and then clustering them into themes, so that you could find related sets of data in unstructured information. All right. So all this was based on reports, websites, information that they scanned, and so on. So this was some of the earlier work back in 2002, right through to 2004, and still Inspire continues to be available today, but it's evolving into new products at this point in time. So we start to see changes in the way information visualization and scientific visualization is dealing with the game. All right. When we saw the dynamic home finder, the data was very structured, was pretty much quantitative. We know what the variables are, and you change them, and if there's missing data, you don't deal with it in the same way as well. But now we find that the situation has changed quite dramatically. A lot of the information is pretty much unstructured in nature. How do you deal with those kinds of information? A lot of the data is now streaming. It's constantly coming through. Your tweets, your Facebook information, news feeds. This information is coming through very often, constantly, and large volumes. And how do you deal with those things? We talk about the 3 V's that some of you are familiar with: volume, velocity, and variety. Yep. So you have those kinds of things coming through as well. So what we're trying to see, what we're starting to see here is this combined analysis, and we're no longer talking about visualization, but extracting meaning. And that's one of the crucial things that you need to start to think about. It's not longer about visualization technology. It's about how do you show to the user what this set of data means. And that requires an understanding of context and other issues as well, which we'll talk about in a short while. How much time do I have?
You have 10 minutes.
Okay. So some of the technologies, like semantic, in order to create this semantic analysis, requires very powerful technologies. The GATE technology at the Sheffield University, for example, allows you to find closeness between data sets. You find that some of the stuff in the your Amazon.com websites, people who bought this stuff as well, is also based on some of these kinds of technologies, right? So commercials are starting to have been using these kinds of ideas already. Now I showed you Home Finder just now, right? Home Finder, you're manipulating the values, the windows, or the gates within which you retrieve the information. It's a filtering process, right? Very important. You need to have those kinds of things. But now we're starting to talk about how do we learn about what's going on in that data set, right? How do systems learn about the data set as well? And as we're doing that, we're starting to come down a different path. One of the issues that we're looking for now is this notion of assembly of the data. In the case of investigative systems, one of the things that we need to be able to do is to assemble the evidence in a particular way that allows us to withstand interrogation in the court of law, for example. Now that becomes a new way of dealing with these things. Now, legal investigations can have an enormous amount of data in terms of paperwork. So if this paperwork can be automatically read, so to speak, classified, made sense, highlighted, and then somebody got to take it out and says, I think these course of events occurred in a particular way that helps me say, Joe Bloggs is a crook because this pieces of data help me fit them together. And then it leads to a whole bunch of other issues which we'll talk about later on. So assembly of our own data in order to construct some kind of understanding is part of the next step of things, not just the visualizations. So many of the tools have come up since then that looks at these areas, and I won't go through them because Ross is going to spend a lot more detail in them. These are some of the other tools that people are now calling visual analytics tools. Again, it's a lot of information visualization. Okay, more tools, more visual forms, network graphs, bar charts, be able to link stuff together and when things occur. Social network analysis graphs as well. Okay, and then people are starting to think about how do you create situations, how do you recreate situations. Okay, so situation recreation is another area of work where timelines become quite useful. So you want tools that allow you to say different timelines, show me intersections between what different groups of people do. And one of the things that we started working on as well in order to look at how this change of data, the focus on the data, so you're now operating on the interface and how the interface helps you assemble knowledge is some of the work which we've been working on. Chris helped me build this, and Chris and Tini helped me build this. Oops, it's not working in. Yeah. Okay. There's something we call the invisic fan, semantic fan. Okay, let me just pause it for a moment. It's playing and I can't see it. Never mind.
This is the semantic fab.
Yeah, the tree map initially. Yeah. Search for a piece of information that you want to extend on, and it gives you more information about that's related to the particular topic. And if you want the specific data sources, you can then drag them out and search them on an invisic interface. So that very briefly was a very quick example of how we made use of tree maps to be able to then incorporate them with different layers of information that allows you to then find related information. Now, the related information that allows you to move from one part of the list to another list to another list is part of the semantic fan, and it was based on some of the rake and cast technology that was developed by the Pacific Northwest National Laboratories, but we implemented it in this particular context. So what we're starting to see here is a change from the visualization pipeline to what is being referred to as a visual analytics model, the visual analytics process. What you can see here, it is not a single directional flow. We're no longer talking about a unidirectional flow. We're talking about constant model building, model visualization, and there's iterative process. Sometimes the data is transformed, and then it's transformed further so that you have new sets of data that's generated from that set of data, which is then used as a means of supporting some of your further analysis. There's mapping of that into the visual formats. There's understanding that you generate, and that knowledge helps you direct the whole process again. So it is that kind of iterative process that we're starting to see that needs to drive visual analytics rather than just visualizations pipeline. From our perspective, we started to think about visual analytics from a slightly larger, slightly different perspective. So in order to highlight and emphasize some of the parts we feel is quite important. One, okay, there's a standard data analysis. Could be statistics, could be machine learning, could be whatever. But you need that component in order to automate the process of summarizing and extracting stuff from the data. And then we have visualization and representation. Now, here's a question for you. If you don't know what you're representing, you can surely as easily visualize anything. So the question is, what is it are you representing? Right? What are the constructs that are important in the interface? What are the important relationships that needs to be shown to the user so that they can make the necessary connections? How do you find out what is it that you need to represent? given a set of data, our tools today allow us to create any visualization very easily and very quickly. But the question is, how meaningful are they? Because if they're not meaningful, they're not representing, it is because they're often not representing the relevant constructs. I think I started 5-10 minutes, it wasn't.
You go ahead.
Yeah, okay. Okay. Because I'm just trying to piece together a bit more. So you need to couple visualization with knowledge about representation design. Okay? How do you create the coupling? Interactive dynamics, there's another area of work over here by Schneiderman here. They've partitioned interaction into different components, and there's a very nice definition of the kinds of dynamic interactivity that's needed in visual analytical interfaces in order to support that kind of quick model building understanding in order to support our and direct our searches and our analysis. Next, all of this then combines into some kind of representation that is tightly coupled in a perception action loop. As I see, I'm able to understand, it directs my search, allows me to connect with the rest of the data again. Now, that is a very important component that's often missed out because we're not talking about interactivity, or most of us don't come from an interactivity kind of background. So as long as we put up a visualization, it's fine. But we find that there's an interactivity that allows us to do a lot of things differently. And we'll talk about some of it in a short while. Now, that combines together to help you understand, make sense of the data. And I don't have enough time to go through much of these details, but it is a whole process of sense making, trying to understand what is it, what's the context, what does it mean, okay? And in order for you to have that, you need a mechanism for assembling your understanding that can then be fed back into the analysis of the guide subsequent analysis of your work. I think in terms of time, I'm just going to skip through this very quickly. Very old piece of work, 1976, Euronizer, in terms of the perception action cycle. Okay. What it basically says is that if you see what's going on, you can then figure out what you need to modify in order for you to, which then allows you to create an understanding of where you're headed, so that you can then change your direction of search and so on. Okay. But this comes from, this kind of process can only occur if there is this very tight coupling, okay, between the tools that you use and the visualizations that you see. It's like a bicycle. Who rides a bicycle? Anyone ride bicycles? Yeah, you all ride bicycles. Wonderful. Right. Now, can you imagine getting a pair of stilts and then try to ride a bicycle where you can't see your stilts on the pedals? No peripheral vision like that. Very difficult. Yeah? You connect a piece of wood to your legs and then you try to ride. Very hard when there is that loose coupling. So what they're trying to say here is that if you can see it, then you can make corrections, you can change, and you can understand what's going on. Now, Misha did this piece of work some time back as part of a PhD. What we found was rather interesting. Now, what you have here is that we did a study that looked at something called the InVisic interface, where it allows you to manipulate cards of information. And you can organize the cards of information that allows you to assemble your understandings that you have. We compared the user interface with the standard website interface for the Citizens Advice Bureau. Same content in the Citizens Advice Bureau. For those of you not familiar, the Citizens Advice Bureau is the organization that supports socially disadvantaged citizens in finding information about health, taxation, social benefits, housing support, whatever. Now, that kind of information is embedded in a very deep and wide website. Now, we took that information and we converted it into the InVisic website. And what we found was that for the low literacy users, not high literacy, but the low literacy users, those who are less socially adept at finding information in the first place, okay, they took 3.2 times longer to complete the task in comparison to using the advice guide, it took 8 times longer to complete the task. Okay? In terms of visiting more web pages, when they were using the website, they had no idea what they're looking for. They're just moving around. Many different websites. In terms of backtracking, they had backtracked 13 times when they were using the standard advice guide. But when you're using the InVisic with us, because it provided a trail of provenance, okay, backtrack only 3 times, okay? And so what we found, you can go through the statistics, what we found was that these kinds of assembling of information in real time allows people to deal with information differently, and their understanding the performance improves. We did another study as well. They look at the ability to manipulate these objects on the interface. And what we wanted to do was to be able to see this in relation to a physical model in the first place. So we got people to look at card sorting exercise, to be able to generate organizations in the data set. And what we found was that when you had the ability to manipulate your card objects, to be able to create, let's say, stories about which animals live in which habitats and ate what kinds of food, you had 99 observations compared to 50 observations of what we call sense-making and creativity tasks. All right? If you were not allowed to manipulate them, you came to a conclusion more quickly, even though it may not necessarily be the right conclusion. Whereas if you have the ability to explore and investigate and move things around, they're more likely to try out different observations, try out different ways of grouping them. So there's another study which I couldn't get hold of the data. Simon has done that with one of the students, and I think it sort of reflects it very nicely as well. But we'll come to that at another time. So what processes do we support then? If we're talking about technology working in aid of humans, right? What is it that we support? What is it that we represent? Right. Some of these things involve essentially sense making, insight generation, inference making, and analytical reasoning. I'll explain very briefly each. For those of you who have been working in the intelligence community, as well as in information search and retrieval, you're probably familiar with this model. It's a very high, sort of a procedural model of how intel officers or people work with data. Okay, they get their data, they organize them, you index them, slot them into what they call a shoebox. Primarily, it's an index card box. Okay, it creates your evidence files, and eventually you then cycle up into creating some kind of understanding of what this data represents. And somehow or other, you generate a hypothesis. And that hypothesis allows you to then test it in the sense of, can I find more information to support this particular thing that I'm suggesting occurs? Which leads to then some kind of a presentation that communicates to somebody further up the channel. While it has been cited often, we find that it is not as useful in trying to explain what goes on here. This particular sense-making loop is not very well explained. And we find that it's quite important for us to look at that area, because that is where visual analytics is actually very powerful at, but it's underutilized and undertapped in that particular area. Okay, so that's where we're suggesting we need to look at. So we started looking at other models. And one of the models that we find that's most useful for explaining what goes on in that particular part of the sense-making loop is something called the data frame model of sense-making. I can't take too much time to explain it, but Gary Klein and his colleagues, and one of them sits way up there, so he's going to tell me off if I'm too far off track or not. Okay. It's the data frame model is how you, it's 4 broad processes. Okay. One is what we call the connecting, and then you have an elaborate frame, a question frame, and a reframing. What happens is simply this: you presented with a bunch of data, you somehow or others seek a way of understanding what that data is. When you make that connection between you and that data, you say, okay, I understand that. When I understand that data, it allows me to then say, what else is there about it? Is there something else that's information that's interesting here? Are there other types of information that can be connected to this? Are there missing bits of data? It helps me understand by elaborating on what it is. And that's the elaboration process. And as you understand further, it leads you to start questioning it. Okay? How do I be certain that this data is valid, or my conclusions are true, or that the assumptions that I made about the missing data that I've seen is relevant? Okay? That comes under your question and frame. And then that allows you to then reframe it that says, oh, maybe my understanding, my explanation now needs to be recontextualized because I have seen something else. Now, it's this process that's constantly going around that we need to be able to support. Not just the very fact that we have come up with a conclusion after searching for the information, but this process of sense making that allows us to draw conclusions about how things work and explain what goes on. Now, what goes on here allows us to then come to this particular model of how we think possibly the analysts could start thinking about. Some of you have seen this particular slide. What we have basically is two ends of a spectrum. On this end of it, we have a very loose story. Okay? I am presented with a bunch of data. I make a few guesses. What's going on? Like an archaeologist, you pick up a piece of a red brick or a tile or something and says, oh, I'm guessing that this place must have been inhabited by Romans 2,000 years ago. Wow. Okay, how the heck do I come to that conclusion? Now, at this point in time, there's a high level of uncertainty. All right? I'm not sure about the data, possibly. So I'm just making a big guess about what it is. And I'm also very low in terms of commitment. I am open to other suggestions. You have to be, if you are down at this end. If you commit at this end to something very erroneous, it could be to something where it's high uncertainty, it could be very erroneous in the end. Okay? And you go through a process of inference making. Depending on your data, depending on the source of information, and depending on the rules and the kind of conclusions you want to make, you use a process of abduction or induction or deduction, and that process goes through, not in this particular order, but what I'm trying to show here is that there's a refinement, and as your understanding increases, you come to this end where your uncertainty decreases and your commitment to a solution increases, and you result in an explanation that is a much more formal argument that is able to be withstand interrogation in, let's say, a court of law. At this end, it is playful. They're talking about creative generation. They're talking about tentative ideas, maybe. So the focus of the tools that you build or you use should be on gaining traction. How do I generate a story that allows me to then direct further investigations? Whereas at this end, it is evaluative. And your critical thinking processes starts to come in place where you're trying to create a definite, a deliberate, a final kind of outcome. Right, and it is then within the context of how you use information that we start to find visual analytics coming through. Now, very often we are presented with what we call the keyhole problem. Okay? Imagine a tabletop. I got to finish off in 1 minute, right? Yeah. Imagine a tabletop. Okay, and everybody knows jigsaw puzzles. Yeah. I take the jigsaw puzzle, 1,000-piece jigsaw puzzle. Turn it over, put it on the tabletop. Now, all I'm going to give you is a small keyhole to sort out the pieces, right? A small keyhole in which to view the pieces and sort them out. That viewer is your computer viewer. Now, problem. That jigsaw puzzle is now taken the box and throwing it away. So you lose the context. And many of the people that we work with in industry don't have one jigsaw puzzle to work with only. They have many jigsaw puzzles, 3, 4, 5, 6, 7 jigsaw puzzles at the same time, with no clock stops. And they need to be able to assemble those jigsaw puzzles, making use of the keyhole in the computer user interface. So how do you create the tools that allow us to then, through that very small window, assemble and create the necessary connections that allows you to then assemble and tell a story about what the data is about? And those are some of the challenges, which is the subject of other talks. Now, to do that, what we've come up with is a notion of what we call the reasoning workspace. Okay? If you split up that space on the tabletop through the keyhole, then what we have is what we call a data space. Right? There's an area that needs to show me what data resides in my data sets. And those data helps me understand what kinds of questions I can ask. So a lot of analytics, summarization comes in here. And then there's the analysis space that tells me about relationships. What are the data that resides, what patterns are there, and what are the interesting stories I can tell from it if I can find the patterns in the data. But an area that is not very well habited is what we call the hypothesis space. It is in the hypothesis space that we start to assemble evidence together or data together that enables us to tell a story. So we move from the analysis through to the assembly and the telling of a particular story. All right, so very quickly, in conclusion, what we're looking for, I'm not going to go through those two bits. What we're looking for at the end of the day. How do you create and generate insight? Or how do you support the creation and generation of insight, making use of visual analytics tools? Okay? And again, that's subject of another talk, but really, what we're looking for is how do you use the systems that enables you to generate those unique assemblies that allows you to explain what the data is about.
Thank you, William.